All right. Well, maybe you started this next video right away because you didn't figure it out. Maybe not. I don't think actually, I didn't keep my solution. So I'm literally building this with you for the first time. But I don't think the data is wrong. I think what I did before is a real simple little check here. So if team.getSalary is 0, skip it. Because if there's no salary data for that team, then it's obviously going to throw everything off. So let's try this. Kaboom. So the best team is proper, the worst team is proper, and you can see in 1987 the Texas Rangers had an attendance of 1.7 million people, and spent $880,000. Um, and they had 75 wins. So that means they had $11,733 per win that year, best of all time. The worst of all time being the 2013 New York Yankees, who had 85 wins, a good total. They probably went to the playoffs with 85 wins, and spent let's see, $231 million. So they had spent a total of 2.7 million dollars per win. So clearly the Yankees that year had a better win total. They actually won more than they lost, but they spent a ridiculous number amount of times for that. That team in Texas really did well. As we're going to see off the attendance, they did really well because they had 1.7 million in attendance as opposed to 3.2. They had nearly double. But the Yankees spent couple hundred times more to be able to generate that attendance. Um, so the average of all teams then was $250,000, and so that shows you something as well, how much more the Yankees are spending. Now that average number might be off actually, because of I don't know that we checked these zero salary ones up above, and so the way we calculate it might be off. And that's again an idea of double checking where it's supposed to be. So if we actually test the average here, that's probably what's going on is we are calculating the average of the wrong spot. So let's come back and clean that one up again real quick. So let's go to our code, and where we are calculating the averages here, maybe let's change where we calculate the averages. So let me do this the simple way. I'm going to comment this out real quick, and that's going to show me through a compiler error where I'm doing this. So I'm going to take this line out here, and I'm going to move that line into my building here. So I'm going to build this down here instead. All right, so I'm going to figure out the salary total down here, and so I'm going to take that one out. And then I'm going to do the same thing with the win count, because I don't want to include wins for teams that have zero salary, and I don't know that at this point in time. Um, so, oops, sorry, I need to go to the build, and I'm gonna, let me just take out all three of these at the same time. Um, the attendance, and I just do them all at the same spot there. All right, so take out that, and put these back in, and build costs, come down to build costs. Um, all right, so let me build these down here, and that might actually make up for that 3-to-1 difference because I'm including a whole lot of salary and wins. There's a whole lot of wins that the salary was 0. Okay, I probably have a divide by 0. Yes, because to get the average, then I also not test the average to get the average. Here, I also need to add my check there if best. Uh, There you go. So we'll double check that, and let's see if I fixed that problem. Yes, I did. So I'm only including teams now that have zero salaries. Now, this isn't to say that you should always wait to go calculate things. Again, in the COVID data analyzer, I can be much more efficient by calculating things all at once up front. But sometimes I have to be aware of how I might be including data that doesn't actually match what I'm looking for. So much better, much better. So let's do test attendance because that's the last one we have out here. So best attendance of all time. So this one, best attendance per attendee all time. So and worst. So I can calculate this in my build, and I should be able to do both of these fairly quickly. So I have these two up here. Best attendance and worst attendance. But I need to add my check here as well. And again, it doesn't matter. I could be checking for any value being null because any one of them is being built in my build cost. But now up here, I'm going to have the attendance to go along with it. So I'm going to copy this as my pattern. I think I'm going to do it at the end just to separate it out. But now I'm not, the cost per win is no longer what I'm looking for. I actually want the cost per fan, essentially, person in the stands. I'm going to use that shorter name. And so the team salary is no longer divided by wins, but by attendance for that year. All right. And so the best attendance, if that's equal to null, or the cost per fan is less than the best attendance, and best attendance, and then the best attendance here. All right, and I need the same thing for worst. So I'm just going to copy and paste. Oops, I don't need the cost per fan to change. That's the same. But now I'm going to say worst, worst, worst. I need to switch my sign. And worst. So conceptually, I'm doing the same thing as I was doing with cost per win, but I'm saying how much did I pay per fan in the seat in salary? So to get a fan in the seat, how much did I pay? Okay, so I've fixed one thing in that this is no longer blowing up, but I haven't fixed another thing. So best of all time is not correct. I expected the Texas Rangers again, but again, I have I end up with the Cleveland Indians. So what happened there? Is my numbers backwards? So let me go look at the test case. If it's backwards, it should be nope. The Detroit Tigers. So is there something I did where the Cleveland Indians actually are better? So $46.69 does not seem to be much better because that other one, if we looked at this number above, is $800,000 for 1.8. That's about 50 cents a ticket. So I did something wrong in my logic, and I got to figure out what. Okay, so here is 85 Texas Rangers was about $6 a team. So there's definitely something wrong in my logic. Let me just go back and double check what the code I wrote. So the cost per fan is the team salary divided by the attendance. And so the best attendance and the worst attendance. So if the cost per fan is less than the best attendance to get team salary divided by wins, and it's greater than the worst attendance. So is there a reason why I'm skipping? I'm actually going to try and shortcut my debugging process here. I'm going to do something real quick. I'm going to make sure I'm not interfering myself with any of this stuff by commenting it out real quick. Make sure I'm not accidentally using one of those variables and I'm not seeing it. No, I'm not. So that part of it is fine. And so let me actually just run this double check. Okay, so I've broken all the rest of my tests, but I've not fixed this one. So it's possible that I messed up. I messed up the test cases here. Um, oops. But it's also possible my logic is wrong. Um, so let me see here real quick. Um, well, let me do a print of cost per fan. And let's see how. Oops, sorry. Python out again. Just about that print line. Let's see how this changes over time when I'm running through the teams. If it does indeed get smaller or larger. Oh no, see, it's not. It's jumping all over the place. So there's definitely something wrong in my logic because I'm not going from largest to smallest or smallest to largest. I'm actually doing that a whole. Oh, hmm. What am I doing? Oh, get wins. Yes, I forgot to change this to attendance. Um, I actually, this is also a good, oops, a good example of sometimes in coding, our answer to the question is inspiration caused by additional data. So what I did here was I printed out one piece of knowledge because what I would expect to happen is this should be going from high to low. It should be getting smaller, 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 kind of like it starts to do here, but then it goes bigger, 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 and it goes smaller, smaller, smaller. And so it's all over the board here. It's because I had the wrong number at the end here, which I only saw, which you might have witnessed right away, when I went off and printed out this extra bit of data. So let me run this again. There you go. I passed all my tests. You can see in this case it went from $6 to $3 to $0. Um, is what printed out here. But oh yeah, zero because I printed out the integer here, but it's 50 cents. So the best team of all time is that Texas Ranger team, as I said, at 50 cents a ticket. So for every ticket they sold, let's say they sold a ticket for $10, they made $9.50 on that ticket. As opposed to Detroit Tigers, if they spent the same $10 on a ticket, they lost $60 and $68 on that ticket. So that means the Detroit Tigers average ticket price would have to be $78 for them to make money on ticket sales alone, where the Texas Rangers would have to spend only 50 cents to make money on ticket sales alone. So anyway, um, that gets to all of our test cases passing. Hopefully this bouncing around gives you kind of a naturalistic feel for what this process is like. This back and forth between the data and the code and inching towards a solution, the use of experience and things you've built in the past, plus also just kind of hacking together a little bit at a time. Um, the things I did here today is exactly what I would do every time I'm building it. I didn't do it just because this is a class. I did it because this is how I build stuff. And remind you, this is the second time I built this. I mean, I built it a month ago, but I still want to be able to get a feel for the data. I made a few short hops of confidence. Sometimes they worked out, sometimes not. But you can see how I can roll back and use my combination of printing stuff out and occasionally the debugger to check what I'm seeing and that it makes sense. So I hope that you can use this to go tackle some of the other exercises here, and that you learn something from this, and that you are a great user of maps when needed in solving problems.